Okie doke, another day, another unit. Let's talk about lines. As you can see, I have white out on my page, but by the time it gets to you, you will have a cleaned up version of these notes. Okay, we are going to model patterns with a constant rate of change. In other words, the constant addition or constant subtraction to a value. And we're going to compute and interpret slope in the context of a situation. So, a couple of recalls. The first being change or difference. What's the difference? How has it changed? Is the new amount and how that differed from the original amount. Okay, so whatever you're calling the original versus whatever you're calling the new, how has it changed and what is the difference thereof, or therein. And I also want to remind you that a unit ratio, so a unit ratio is still a ratio, but it's equivalent with a 1 instead of numerical values that are other than 1. So a unit ratio has been simplified to an equivalent form with a 1 as in it. I'll just put in it. Or as one of its values. So a unit ratio is an equivalent ratio. It has been simplified and in order to have a 1 somewhere in it. Okay, let's take a look at example 1. Price of a chip. Now we've seen this before and we're revisiting this. Notice there's a spot for pattern here. What is the change in price from one year to the next? Well, I see a pattern. +5, +5, +5, +5. It is certainly increasing in price, and each year it goes up $5. What is the change in price from one year to the next? Change in price. So new amount minus original amount, increased by 5. So change. The change is 5. I'll actually write it. Write the change in price as a ratio. Remember to label your ratio with its units. So the change in price as a ratio. So I said every year that goes by, it increases by $5. So let's see, as a ratio, $5 per 1 year. Yeah? Or if you want to write it like this, $5 per 1 year, or in 1 year it increased by $5. However you want to write it, but nonetheless, the change in price here is that ratio. Is this pattern linear or exponential? Well, previously we had a section where we talked about linear being a constant addition or subtraction and exponential being a constant multiplier or divisor. So this one is linear. How can we tell? Constant addition. So a constant add or a constant amount of additional change for each additional year. So how can I tell? Constant add 5 pattern. Yeah. Use the pattern to write an equation for this situation. Okay, and I vaguely remember that we had filled this in and said this is 2 plus 0, This is 2 plus 5. 12, and by this I mean 7 is 2 plus 5. 12 is 2 plus 2 5s, or 10. And 17 is 2 plus 15, or 2 plus 3 5s. And 22 is 2 plus 20, where 20 is 5 added 4 times. Yeah? So we had used how many times 5 was being added in order to write it like this. And we could even rewrite this 2 plus 5 as 2 plus 1 5 added. Okay, so 2 plus 1 5. 2 plus 0 5s. Just to complete this pattern. So use the pattern to write an equation for this situation. Okay, so it looks like these numbers 0, 1, 2, 3, 4 match the year since 2000. Clearly describe what each variable represents. So I don't know, let's call T for years, T for time. I'm going to go with T for time here, and I'm going to go capital P for price. So my T equals years since 2000, and my capital P equals the price in dollars. Price in dollars. And my equation then is that the price is equal to 2 plus however many 5s, and each year it adds another 5. So this is T right here. So 0, 1, 2, 3, 4, and T. So this would look like okay, 5 added T times, or T5s. So 2 plus T number of 5s, or 5 added T times. Got it. Let's do this again. Depreciating values. You buy an item that costs $2,000. It depreciates by $50 per year. Write a ratio, again, painting. Write a ratio to describe the rate of change that happens to a price. Be sure to label it with units. Okay. Ratio that describes the rate of change that happens to the price. Oh, ratio depreciates $50 per year. So actually, I'm going to write that this ratio is negative $50 per 1 year. Or if you want to write it like this, negative $50 in 1 year. Or you could write in 1 year it goes down by $50. Yeah? Make sure when you're writing a ratio, you label it clearly with units. This is one of the things that differentiates fractions from ratios. And I mean, $50 per month is a lot different than $50 per year. So make a table of values to keep track of the item's value over time. Oh, okay, got it. So we'll go time, and it looks like it's in years. And worth. Okay, so it says keep track of its value. We'll call it the worth, and we'll keep track of that. Okay, so if 0 years have passed, it is originally $2,000. So it's worth, let's put this in dollars, $2,000. Got it. After 1 year, it has depreciated by $50. So $1,950. Got it. Okay, I'm feeling the pattern. Take away 50. Another year has gone by, and it is only worth $1,900. Another year goes by, $1,850. 4 years go by, $1,800. 5 years go by, and now it's only worth $1,750, etc. Okay, so here's our table to keep track of the value or the worth of the item over time. It doesn't say what it was. Probably like a copying machine, if I had to guess. I don't know what else is about $2,000. Anyway, how was the ratio used when you made the table of values? Well, it told me right off the bat how it's going down. I increased time by 1 year, and I decreased the worth by $50 each time. So the ratio actually told me how to change my time and how to change my worth. How was the ratio used? Well, it let me know how to change the time and worth. To keep, yeah, okay, so it let me know how to change the time and the worth. Yeah, I'm just gonna put a period. Is this model linear or exponential or neither? Oh, well, in order to see that, I need the pattern. Okay, pattern. The pattern was down 50, subtract 50, keep on subtracting the same constant amount, linear. This is a linear model, and I can tell because of the constant subtract 50. How many years will it take before this item is worthless? Oh, I see. So if it's $50 a year, how many years until all $2,000 are gone? Okay, so I'm looking at this and I'm thinking a little bit. So when I think about this problem, I think it's asking how many 50s are in 2000, because then really, you know, it's starting at 2000, it's going down 50 per year. How many times does it do that? So how many times does it do that? This is a division problem. 2000 divided by 50. What is that, 40? Because 4 times 5 is 20. Yep. 40 years. So it takes 40 years to be worth. 40 years later, it is worth $0, $0. Okay, so now there are different ways you could have solved that. I went with division because I thought that would be the quickest route, but you could keep doing this minus 50 all the way down. I have had students in the past do this thing, which is crazy cool. I've had students come up with the equation. So off to the side, if you're like, why didn't you just write the linear equation for this? Whatever. So I've had students who, when they were solving this, actually write, we are doing $2,000 minus $50 each year. Now, I don't know if they call it T or whatever, and then they will call this worth or value, whatever. And then they actually put a 0 here and solve this equation because they have some old skills that they're like, I remember how to do this, and then they do it, and then they solve it. Totally fine by me. Sometimes people actually write this out and then try to guess and check what number goes in here. Totally fine with me. All of those will get you to the point where 40 years later it is worth $0. Okay, so as long as your math is correct, I'm very happy and content. Now, if you're not labeling things, then I would not say that your mathematics is completely correct. Okay, so if you just say $50 in one what? That's not completely demonstrating, that you know what that is. So make sure you label. If you're going to solve something, make sure you show your thought process. That way I know what you're thinking, and I know if you're thinking along the correct lines or the wrong ones. All right, in the next video, we'll take a look at some population and whatnot.